Section 3.6, Polynomial and Rational Inequalities Part 2. Let's go ahead and now figure out how do we solve rational inequalities. It's very similar to solving polynomial inequalities where one side of the inequality has to be set to 0. In this case, it is, so we don't have to do that part. And then we have to factor. Now with polynomials, we only had one thing we had to factor, one thing we had to worry about. But with rational inequalities, we have to factor both the numerator and the denominator. So let's go ahead and do that now. Now, the numerator is only x minus 2, therefore there's nothing to factor there. But what does the denominator factor out to? If you said x plus 3 quantity squared, you are correct. Okay, so let's go ahead and do that. Next, we want to write all our zeros from the numerator and the denominator on our number line. And recall that when we had just the polynomial, we did the same thing, but now we have to do it for both the numerator and the denominator. And let's go ahead and do that now. Okay, so from the top, from the numerator x minus 2, I get 2. And from the denominator x plus 3, I get negative 3. The other thing we need to determine is whether we have open or closed circles. Okay, something you have to be very careful about. Now notice that we have less than or equal to 0. That means that we do want to include our zeros, right? So what does that mean? That I place closed circles here because it says less than or equal to 0? No, that does not mean that. You're probably thinking, what? Didn't she just tell me in part 1 that if I have less than or equal to 0, then I include them? I did, but now we have a denominator. So we have to remember that we cannot have a 0 in the denominator. So whether your inequality is less than 0 or less than or equal to 0, whatever 0 came from the denominator, it is always an open circle. So negative 3 came from the denominator, so we have an open circle. Remember, you cannot have zeros in the denominator, and negative 3 makes the denominator 0. Now, since we do have less than or equal to, we do want to include the 2. Okay, so this is the tricky part of rational inequalities, remembering that we never want zeros in the denominator. Okay, so, and then I put there, note the zeros that come from the denominator are always open because they are undefined. And then we're following the same steps for the polynomials from 4 to 6, where we now have to determine whether I have positive or negative intervals. So let's go ahead and I'm just going to copy and paste. I don't have to do it again. Okay. So in this case, we are plugging in a value from each interval into x minus 2, x plus 3 quantity squared. And then again, so in the interval negative infinity to negative 3, I'm going to choose a huge number like negative 1,000,000. So if I do negative 1,000,000 minus 2, I get negative in the numerator. And then in the denominator, I'm going to do negative 1,000,000 plus 3 quantity squared. Since it is squared, it is positive. And a negative over a positive, I'm actually going to move this just to give me a little bit more of space in the bottom. A negative over a positive gives me a negative. I'm again going to use my shortcut. If I think about where negative 3 came from, it came from x plus 3 quantity squared. The power is even. So because the power is even, my next sign is going to stay the same. So I have a negative again. And then the 2 That came from the numerator, which has an odd power. There's a imaginary one there, has an odd power. So now the sign's going to change. So it went from negative to positive. And if you want to double check, you always can. So if we plug in, let's say 1,000 here in this interval from 2 to infinity, 1,000 minus 2 is positive, and then 1,000 plus 3 quantity squared is positive. So a positive or a positive gives me yet again a positive. Okay, so you can always check if you want. Okay, so now we're not done, right? Do we want to shade or highlight our positives or our negatives? So we go back to our inequality. Notice this means that we want all the negative values, less than or equal to 0, all the negative values. And therefore, we shade negative infinity to negative 3 and negative 3 to 2, and we finally can write our answer in interval notation. Okay, notice that I place parentheses for our open circles and brackets for our closed circles, and that is our final answer. All these values in these intervals, all these x values in these intervals make our inequality less than or equal to 0. Now you try. So I wrote down here five examples. If you need to pause the video, actually you should be pausing the video to do these problems. And once you're completely done with these problems, you can come back and look at the solutions. Hopefully you're done, and now you're pressing play, and I'm going to show you the answers for questions 1 through 5. And again, you might want to press pause so that you can check your answers. And that's all for this section. Thank you very much. Have a great day.